All right, so good evening to my lecturer. So this is for the question one. So for question one, the question is given equation which is x equal to 7 exponent a multiplied by t. So for the a, we are going to use from 1.0 till 2.5. So this is the equation, the command. So for the plot for the first graph, which is a equal to 1.0, while t for the fourth graph, the t is all the same, which is from -3 to 3. So for graph number 2 is a equal to 1.5. So the third graph is equal to 2.0, and the fourth graph is equal to a equal to 2.5. So what do we get after we run this program? So we will get a graph which such as like this. So for the first graph is a equal to 1.0, so we will get this graph. And for the xt is from 0 to until 150 for maximum. For b is equal to 0 to 700, 0 to 300, 3000, and 0 to 14,000. So that is the difference that we see between a equal to 1.0 and until a equal to 2.5. Okay, so that is for question one. So for question two, what do we need? So for question two, we are asked to transform the following time domain to the inverse Laplace transform. So this is a partial fraction of the equation. So how do we want to get it? So it's a equal, so we put the a which is for the numerator, which is s equal to 1, and the last digit with s power 0 will equal to 1, so the number of it is equal to 7. So b is for the denominator, which 276, and the last is 0. So for the number of 0, we can choose to write or not to write it, as it will not change the final answer that we get. So for ft, we are going to do the inverse Laplace transform. So where we will get the r, p, and k for the inverse Laplace transform. So this is the question for task 2. So for task 2, it don't have the graph, but we have the value that we get, which is r equal to -5 and value of 5.5. For p is -2 and -1.5. For the k is the equation that we get is exponent to -2t times 5, which is equal to 5 exponent -2t divided by 2 minus exponent -3t over 2 times 11 divided by 3 plus 7 over 6. So this is the final answer that we get for the inverse Laplace transform. So next, for the question number 3. So question number 3, it asks us to obtain the poles and zero of the following transfer function and plot the system using the poles zero plot and transform the following to time domain. So how do we want to get? So same goes with question number 3. It is the same as the question number 2. So only that we are going to do the graph. We are going to plot the dot plot, which the graph will have the zeros and the poles. So how do you want to plot it? So for plot it, we will use the numerator and the denominator, same thing. And after after that, we are going to use a command which is known as h equal to I ops plot. So this is allow us to plot the zeros and poles in the a graph. So and next is to do the inverse Laplace transform. So what do we get? All right. So for number 3, so first we will get a thing such as like this. So we will have the 0 here, 0, 0, and the 2 poles. So we know the position of the poles and 0. So we also know that the R, P, and K, which we get the final answer of the after we do the inverse Laplace transform. So that is for the question number 3. So what goes for question number 4? So for question number 4, it asks us to do the task, which to find the position of poles and 0 by using the given function. So, and second task is to inverse Z transform. And third is to plot the plan, the Z plan, and determine its stability, whether it's stable or unstable. So this is the command, which the same thing goes for numerator and denominator, the residue, only that we are using the Z transform, which is not the inverse Laplace transform. So we are going to use y equal to iz transform of x of the equation that it gives. So for here, right, I clear the command first. All right. So for here, we can see that we have the answer here. For the Z transform, we will have the equation with the poles and 0, the position. So we have a 0 and a poles outside the unit circle. So what do we mean? So it means that it is an unstable. Why? Because it have a poles and 0 outside the unit circle. So now, how do we determine its causal? So causal, we will see the poles. Poles is at the right side of the 0. So for that, we will use it. We will determine that it is an anti-causal. Why is anti-causal? Because it is the poles are on the right side of the 0, and it will form a donut, and shape of donut, which the shader of region will in between of the outer circle and the inner circle. So that's all for the 4 tasks of the lab test. I think that's all from me. Thank you.